Hi, I'm Abby Wingo. I was interested in our topic of storing carbon dioxide emissions underground because it directly impacts our quality of life as humans if the carbon emissions do decrease. My contributions to this project included finding most of the research and the links that we used, the timing for each section of the video, and the social impacts of CCS.
I'm Eric Fan. I was interested in this topic because it was one of the biggest challenges that our generation is facing right now. My contributions to this project include investigating the scientific portion of CCS and editing the video.
Hello, my name is Ami and I am interested in new inventions and technology related to chemistry and physics. I contributed to the economic perspective of this project, conclusion, and the mind map.
Let's evaluate the plausibility of their claims and see what some outside sources have to say about this idea. The CCS organization proposes a beautiful solution to global warming: capture carbon dioxide from waste-producing sources such as factories and power plants and store them underground where existing carbon-containing earth is found. They provide two ways to capture the carbon dioxide. Both pre-combustion and post-combustion storage methods involve either a shift reaction from carbon monoxide to carbon dioxide or separating already produced carbon dioxide from the air. If everything were to work as described, then this would be an ideal solution to global warming. However, they do leave several steps of their process out. These could be parts that may or may not work if implemented in actual life. CCS does not mention how the shift reactors and liquefaction of carbon dioxide will work, but deeper research has shown that these are indeed possible. This document here shows how the carbon monoxide to carbon dioxide reactor will work. And University of Illinois provides the answer for liquefying carbon dioxide. The correct way is by applying the correct amount of pressure, you can indeed liquefy carbon dioxide. So now, there seems to be nothing wrong with their entire process. However, all of these processes still require an input of energy, and CCS includes on their informational site that they'll get this energy from renewable sources like biomass. The only thing that's preventing these from being universalized right now is that they're not cost effective, as any country that have tried to implement them in the past have gone deep into debt, so this is not cost sustainable. However, even if we assume that these renewable sources are sustainable enough to power the 10 million plants in the world who would use them continuously, it would still cost significantly less to generate electricity directly from renewables rather than to power CCS. Greenpeace proves that collective costs of capturing, liquefying, and storing costs over twice as much as wind energy and geothermal energy, and 40% more than solar. It seems that this part they left out of their beautiful solution might pose a huge problem for any country trying to actually implement it.
Okay, so I am going to talk about the cost of CCS, focusing on these three main steps. Step 1 is to capture CO2 from coal-fired power plants, and it needs some special equipment which are not used in general power plants. So we need to either build new power plants or remake the old ones. Step 2 is to condense CO2 into liquid form, and high pressure and low temperature are required for condensing CO2, and it costs about 600 kilowatt-hour per 1 ton of CO2. Step 3 is to transport CO2 to bury underground. Transporting CO2 for 300 kilometers costs about $7 per ton of CO2, and to maintain the flow, we need this specific temperature and pressure. So a lot of energy is used for these three steps, and CCS power plants reduces about 28% of energy generation. And this use of energy makes the electricity cost 80% higher than the without CCS. So this graph compares the CCS cost of CCS with other powers, and it is apparent that CCS costs a lot more than other clean and renewable energies. Overall, CCS requires bunch of energy and money, so we can conclude that CCS is not very effective from an economic perspective.
Dr. Joshua White, a researcher at the Lawrence Livermore National Library in California, said, quote, "There were always some expectation the CO2 would migrate from the reservoir a little ways up to the cap rock, but to his and his colleagues' surprise, the CO2 started to appear at wells not too far from the injection site. In an experiment conducted by Eugenio Rastelli from the National Center of Biotechnology Information, Research was found that proved CO2 leakage under the ocean decreases the pH level of the water, effectively killing thousands of organisms. Several other instances have occurred where the injected CO2 has created disasters, including a series of several uncontrollable blowouts in Mississippi. In Yazoo City, the pressure put on the wells from the CO2 was too much, causing a rupture, leaking enough CO2 in the air to where the deer and the other animals were suffocating. This leaked CO2 also impacted two of the biggest water sources in the county, making the water contaminated and unsafe to drink. Finally, to transport all of this captured CO2, Pacific Northwest National Library estimates up to 23,000 new pipelines are needed, and almost certainly the funds for these new pipelines will come from the taxpayers. This puts a huge strain on the people and makes them unhappy if their money is going to waste for a system that isn't proven to work.
Scientifically, the logic of CCS makes sense, but it requires energy from renewables and it does not solve the problem overall. And CCS project needs a lot of energy in its process and it costs a lot of money.